We have studied the various types of energy sources. Now these resources of energy are divided into two groups, renewable resources and non-renewable resources. As the name suggests, non-renewable resources means if you use that source, then it gets diminished. For example, you have 100 rupees in your pocket. If you spend 40 rupees, 60 rupees will remain with you. So same thing happens to this non-renewable sources, like if you are using coal, oil, gas or any fossil fuel in thermal power plant or in operating the vehicles, they are getting diminished because its formation has taken millions of years in converting the dead plants and animal into this fossil fuel. And our consumption pattern is such that we are removing at a much higher rate as compared to its formation rate. So these are called non-renewable fuels. And other thing, this non-renewable fuels also causes pollution. Then what are renewable sources? They are not getting exhausted, or their life is much more as compared to non-renewable resources. For example, wind energy. There is a cycle that in certain seasons wind energy would be more, certain period it would be less, but that cycle is repeating since long and is expected to repeat in future also for a very long period. Tidal energy, same thing. Solar energy is going to last for a very long period of time. Sun is not getting cooled down in small period of time. Potential energy of water that is stored behind the dam is also considered renewable because the rain cycle is repeating and it will continue to repeat. So they are called renewable sources of energy. Even nuclear fuel, sometimes we say it is renewable because the availability in the world is such large and our consumption is very small, so it is negligible. So we say it is also coming under renewable sources. Okay. Now we will try to see what are the energy transformation taking place in various devices. This you might be aware, like solar panel, solar furnace. Input is solar, output is heat. Solar cell, input is solar, output is electrical. Burning of fuel, coal, gas, oil. Input is chemical. Chemical reaction take place and they produce heat energy. Steam engine, input is heat, output is mechanical. Electric bulb, input is electrical, we supply electricity to the bulb, it gives heat and light. Hydroelectric power station, input is potential energy of water, which gets converted to kinetic energy of water, and kinetic energy of water gets converted to kinetic energy of turbine, which runs the armature and electricity is produced in the generator. Nuclear energy, input is nuclear energy, output is heat energy, which gets converted to electrical. In dynamo, we rotate, so input is mechanical, output is electrical. In motor, it is reverse. We supply electricity and output is mechanical. Electric geyser, we supply electrical, output is heat. In loudspeaker, we supply electrical, output is sound. Thermocouple, we heat one end and output is electrical. Burning candle, input is chemical, output is light. Microphone, we speak, so we are giving the sound energy, it gets converted to electrical, which is transmitted. Photosynthesis, input is light, output is chemical. So this is how sometimes one or two devices are given and you are asked to state the energy conversion taking place. Now we will study two important principles. One is degradation of energy, other is principle of conservation of energy. Now degradation of energy means we are giving energy in one form, we want the energy in some other form, but it not only produces the energy in other form, but it produces in some other forms also which we are not interested. So that energy becomes useless to us. So we say that is degradation of energy. Example, when we are lighting a bulb, we are interested in light energy, but it also produces heat energy. So heat energy gets wasted in the form of radiation to the environment. In all machines which are rotating or which are moving, some amount of energy is lost due to friction. It produces heat. So we put lubricating oil and all these things to reduce the friction or to reduce the formation of heat energy which is not desired. In the vehicles, the flue gases which come out carry some heat energy. So that is not useful to us. So that is why the energy which is not useful to us, so our output energy would not be equal to input energy. So input energy would be equal to output energy plus energy lost in other forms. So if we take into account all the energies that are getting formed, then the input would be equal to output. This is called conservation of energy. So we say energy in the universe remains same. Energy can neither be created nor destroyed. It only changes the form. Like, so we say, simple examples, even total mechanical energy remains constant. So means whatever is the potential energy gets converted to kinetic energy, or whatever is the kinetic energy, the same amount of energy will be get in the form of potential energy. Is it all right? So like water which is stored in the dams has a potential, it gets converted to kinetic of water. Then it rotates the turbine, gets to rotational kinetic energy, which goes to generator, which produces electricity. Now in each transformation, it gets converted also into some other form which is not required by us. So degradation of energy is taking place. Is it all right? So now we will discuss the theoretical verification that mechanical energy remains same. So be more attentive. See, I am having a body at height A, at height H, at the position A. This is the ground. Now if I drop this body, it will finally reach the ground at point C. I am also considering a point B in between, where it has dropped by height x. Now we will try to see what is the potential energy and kinetic energy at each point A, B and C. Means we will see the total mechanical energy at point A, we will see the total mechanical energy at point B, we will see the total mechanical energy at point C. So let us first start with point A. At point A, body is initially at rest, so it is not moving. So kinetic velocity is 0. So kinetic energy at point A is 0. So kinetic energy at A is 0. Now at height h, what is the potential energy? At height h, always potential energy is mgh. So this is my potential energy at height h. So what is total mechanical energy? Kinetic plus potential. So 0 plus mgh, so answer is mgh. So this is my total energy at point A. Now let us come at point B. This is very important. The body has dropped by height x. So displacement is x. Initial velocity is 0. So I will get Vb square. Velocity at point B is equal to initial velocity is 0. Acceleration is g. It is due to gravity. So 2gx, height is h. So my Vb square is 2gx. So my Vb square 2vx, What is my kinetic energy at B? Half mvb square. So half m, this is the value of vb square. So 2 will get cancelled, I will get mgx. So this is my kinetic energy at B. So my total energy at B would be potential plus kinetic. My body at B means it is at height h minus x above the ground. So my potential at B is mg into h minus x height. So my total mechanical energy would be kinetic, which is 2gx, potential, which is mg into h minus x. If I simplify, I am getting mgh. So my total mechanical energy at A and at B is same. So let us see at point C. At point C, the body is brought by height h, so s is h. If we are carrying out similar calculation, we will get Vc square equal to 0 plus 2g into height is h, so 2gh. So this is my V square. So this is my V square at point C on the ground. So my kinetic energy half m Vc square. So half m into 2gh, I get mgh. Now at point C, the height is 0, so potential is 0. So total is mgh, which is kinetic. Potential is 0, so total is mgh. So if I observe at all 3 points A, B and C, at all 3 points A, B and C, I am getting the same mechanical energy mgh. So this is theoretical verification that my total mechanical energy will remain same. Now let us do one application on this. We are taking a simple pendulum. See, this is a pendulum. This is a small ball. Now the pendulum goes here. When pendulum comes back, it will travel on this side. It will go here. This is my point of suspension. Now this height. This is called, this and this are called extreme position, and this is called mean position. So the difference in height in these two positions is h. So at the extreme position, I have got potential energy because my bob is at a height h as compared to mean position. In mean position, I don't have potential energy, but I have kinetic energy because the potential energy at extreme position has got converted to kinetic energy, and now due to this kinetic energy, my bob is moving further on the other side. So here my potential energy is mgh, here my kinetic energy is half mv square. So total energy would remain same. So this kinetic energy is 0 in mean position, kinetic is half mv square. So and this total is whatever energy I was having here. I was having total mechanical energy mgh in this position because here kinetic was 0. So if I equate half mv square, this is the half mv square is, this is kinetic at mean position. This is potential at extreme position. Here k is 0, here z is 0. So total will remain same mechanical energy. So if I equate these two now, because adding 0 here has no meaning, so I get V equal to root 2gh. So if there is no friction, means no loss of energy, so total kinetic energy, total mechanical energy is conserved. So this is verifies principle of conservation of energy. Now in the next class I will do numericals on this chapter. Thank you.